Hello, Matem 2 students. How are you today? My name is Teacher Marius, and this time we are going to look at Unit 5, Parallel Lines. We are going to be looking at parallel lines. Okay, so parallel lines are lines which do not meet, no matter how far they are produced. So look at these two lines. We say that they are parallel because they cannot meet. Okay, we use arrows to indicate that the lines are parallel. So when you see this kind of arrow and this one, then you have two or more lines. Note that those ones are called parallel lines. These arrows, this and this, they mean that these two lines are parallel. And when we say that the two lines are parallel, it means that these two lines cannot meet, or you may say they cannot intersect, no matter how far they are extended. So this is a pair of parallel lines. Okay, so here we have three lines that are parallel. How do we know that they are parallel? We look at these arrows. When we see these arrows showing the same direction, it means that these two lines cannot meet. And if they cannot meet, then they are parallel lines. So these are three parallel lines. Okay, I hope you understand that. So whenever we talk about parallel lines, I want you to get to understand that these are lines that cannot meet. Okay, I hope now you understand what parallel lines are. Okay, so parallel lines lie in the same shape. Look at this shape. It's a cuboid. But within this cuboid, we have many parallel lines. So some of them, we have this one. Here we have two parallel lines. So it means that once you extend this line and you also extend this line, they will never meet. Why we say that they will never meet? It is because the distance between them is always the same throughout. Also here, we have this one and this one. They are parallel. Look at these arrows. They mean that this line is parallel to this one. Okay? So to make it much clearer, now we can say that this one is parallel to this one. We are having two arrows to mean that this one is parallel to this one. Then here we have one arrow to show that this one is parallel to this one. So this line is parallel to this line. Then this line with the two arrows is parallel to this line. I hope you understand that very well. Okay? Okay, so when two lines AB and CD are parallel, let me use this symbol to show that these are lines. Okay, so when two lines AB and CD are parallel, we say that line AB is parallel to line CD. You can say that AB is parallel to CD, or you can say that CD is parallel to AB. It means the same. So someone can say AB is parallel to CD. Another one can say CD is parallel to AB. It means the same, okay? And why do we say that they're parallel? We say that they are parallel because the distance between them is the same. And also, we look at these arrows. Once you look at the arrows, it means that the two lines are parallel to each other. In other words, the two lines cannot meet. I hope that is also clear. Okay, so the above pair of parallel lines can be denoted as line AB, line AB is parallel to line CD. Or line CD is parallel to line AB. I hope that is understood. So when you see these two lines, this one and this one, note that they mean parallel lines, this one and this one. So it means that AB is parallel to CD, or CD is parallel to AB. I hope that is very well understood. Okay, so something also that is important for us to know is that when we have got line EF and line GH, we say that these two lines, EF and GH, are straight and they are perpendicular to CD, and line AB is parallel to line CD. So the line segment EF and GH are straight and perpendicular to line CD. When we say that these two lines are perpendicular, it means that they meet line CD at 90 degrees. This symbol means 90 degrees. Okay? And AB is parallel to CD. Okay? So, line segment EF, we know that it is perpendicular to the line CD. Okay? So, it shows the distance between line AB and line CD at E. Okay? The line segment EF is the distance between line AB and CD at point E. At this point, so the line segment EF shows the distance between these two lines, AB and CD. And the line segment GH, the line segment GH shows the distance between line AB, this one, and line CD at point G. Okay, so what do you understand here? You should be able to see that line segment EF is equal to line segment GH. And if line segment EF is equal to GH, then it means that line AB is parallel to line CD. Okay? So, since the distances between the parallel lines are the same, then EF is equal to GH. Okay? So also, when we say that line AB is equal to line CD, then it means that the distance between these two lines is equal. And then if the distance is equal, it means that EF is equal to GH. I hope that is clear also. So, from what we have seen, you should be able to understand that straight lines with the same distance between them are parallel. When you have two straight lines and the distance between them is equal, then we say that those two lines are parallel to each other. Okay. Now look at this diagram. So it shows that line segment AB is parallel to line segment DC. You see that? AB is parallel to DC. How do we know? Mark. This is one arrow and this is another one arrow. So this one is parallel to this one. Then BC is parallel to which one? Think about that. These are two arrows and these are two arrows. What do you think? BC is parallel to which one? Okay. Now, a line that cuts parallel lines is called transversal line. Now, here we have got two parallel lines. The two lines, it means that they cannot meet. Okay. Now, if we get a line and it cuts through these two lines, this line, we call it transversal line. Transversal line. This is a line that cuts through the two or more parallel lines. And this transversal line is very, very important line in this topic of parallel lines that we are looking at. Okay? So we are going to understand the importance of this line as we go further to deal with parallel lines. Okay, now I give you an exercise here. So you may pause the video and try to measure the distance between the two lines in number 1, 2, 3, and 4. Measure the distance at EX and measure the distance at EY. If the two distances are the same, then those two lines are parallel. If they are not the same, then the two lines are not parallel. Okay? Now, for instance, I will answer for you this one. Number 1, I will say that EF, line EF, is not parallel to line XY. Why? Because the distance EX is not equal to the distance FY. Okay? Now, let me answer for you number 2 also. Then for you, you answer 3 and 4. Okay, I've finished measuring. So, A, B, line AB is parallel to line CD. Why? Because the distance AC is equal to the distance BD. Okay, now you can answer number 3 and number 4. Okay, now two straight lines in the same plane are parallel if and only if they do not intersect. If they intersect, not that to intersect Intersect means to meet. So if they meet, then those are not parallel lines. But if they do not meet, then we say that those are parallel lines. For instance, these ones, they are not parallel lines. Why? Because they will meet. If we extend this line and we extend this line, you see they will meet somewhere like here. And if they meet, then it means that these are not parallel lines. But these two lines, we say that they are parallel lines. Why? Because the distance between them is the same. In other words, they will never meet. So I hope you have understood what we call parallel lines. So let's stop here for today and we meet again next time. Goodbye.